Okay, so this is the solution for the Coulomb's law question. So if you look at the force, the magnitude of the force between charges 1 and 2, that's going to be equal to K times Q1 times Q2 divided by R12 squared. And we're just dealing with the magnitudes here. Because these are opposite charges, this charge is going to be pulled towards that charge, and this charge is going to be pulled towards that charge. Likewise, these are also opposite charges, so they're going to be pulled towards each other. So these two, we're looking at these two forces right there, and they have to be equal to each other, so that the net force, since one's positive and one's negative, equals 0. So we just have to set the magnitudes equal to each other. Also, because they're all in microcoulombs, we can be a little bit loose with units. So instead of having all these 10 to the minus things, I'm just going to include it. Now, you can't do that in general, but so these are the magnitudes of the force using Coulomb's law. And as I said, the magnitudes just have to equal each other. So you can just set the right-hand sides equal. Like that. And because they both have Q2, those are going to cancel out. K's cancel out. So we can solve for this distance R23 squared. So if we take that, move that up to the numerator, move this up to the numerator on the other side, just do shifting these things around, we'll end up with Q3, absolute value of Q3 divided by Q1, and then we're going to multiply by R12 squared. So you get this, when you get these proportions, you can just shift things from one side to the other, just move things from the denominator to the numerator, denominator on the right-hand side to the numerator on the right-hand side, the denominator on the left-hand side to the numerator on the right-hand side, numerator on the left-hand side to the denominator on the right-hand side. And then we can take the square root. Again, we're just talking about positive quantities here. So you're going to have Q3 over Q1 times R12 squared. So now we can just plug the numbers in. So the distance R23 is the square root of Q3, which I'm just going to use the magnitude. Again, I'm going to use 6 instead of 6 times 10 to the minus 6 because it's going to cancel out anyway. Well, I'll just put it in there, 10 to the minus 6. And then Q1 is 2 times 10 to the minus 6 and 50 centimeters. So we're going to get our answer in centimeters. And, because Q3 is greater than Q1, this is going to have to be further away because they're both interacting within 3 microcoulomb charge 2. So that number should be greater, which it is because 6 divided by 2 is greater than 1. Okay, so we're going to take the square root of 6 divided by 2 times 5 squared. And so R23 is going to be, oh, this is 50, not 5, right? 50 centimeters. Okay, so let's try that again. Square root of 6 divided by 2, which is 3, times 50 squared. and we get 86.6, so we'll say 87 centimeters. So that's the answer. X equals 87 centimeters. Now, even though this charge is 3 times this charge, because the force decreases with 1 over r squared, it doesn't have to go as far. So if you take, I think if you took the ratio of this to this, and then took the ratio of the distances and squared it, so if you take 87 divided by 50, and then you square that, you'll get 3. So that makes sense. Okay, so that's it.